Alright, so I'm making another video right after another one about integration, but this one is going to be about the average function of x, so fx average, right? And how do we find this? How do we find the average value of a function? And keep in mind all of this. That's the final equation we're going to work towards. It's very intuitive. This video is going to be like 3 minutes long, so bear with me. So let's say that we have a function, right? A function fx over a range x. Sorry, and I forgot to put that this equation is a to b. So let's say that this function looks like this. This is fx. And let's say that from a to b, we want to kind of find the average value of x, which I'm guessing is somewhere like around here, maybe. That's the average value of x. Obviously, somewhere exists along this line the average value of x. But how do we find it algebraically? How do we find it? Well, what we do is we simply take the value of x, a value of fx here, plus the value of fx here, plus this, plus this, plus this, plus this, all the way until the end. And then we divide by total. Remember, the average between, let's say, 1 plus 2 plus 3. Oh, sorry, the average value between 1, 2, and 3 is simply 1 plus 2 plus 3 divided by the number of samples, which is 3, which is 2. 6 divided by 3 is 2. Whatever. But that's the same thing. We're just adding the different values at different points and then dividing by the number of samples to get the average value. Well, how do we do that? If we think about it, when we integrate, right, there's this little small length, right, this little thing. And basically, if this, right, and remember that when we integrate, like when we split up the equation, this length here is dx. So when we use a small enough dx, the line is so thin that it's basically got like barely any width. And instead of finding the area, right, this is still big enough to find the area. But if we, instead of finding the area, we just find the height of the equation, right? And that's the point. We want to find what the value of each of these points on the line is, which is just correlates to the height. So what we're saying is, but we'll get there later. So anyways, how do we do this? Let's think about this. We want to find the value of, let's say this is x1, this is x2, this is x3, all the way until like x, like nearly b, right? So what we're doing is we're taking the value of f at x1 plus the value of f at x2 plus the value of the function of x3, at x3, plus all the way until the value of the function at xb. What are we dividing it by? The sum of all the values divided by the number of samples. How do we find the number of samples, right? There's somewhere in here that gives us the value of n, some number of slices that we've made. Well, if we think about it, remember what I was talking about? The slices become so thin, but it's still got a width, right? It's a width of dx, right? It's so thin, but it's still got a width of dx. Well, if we had a box, right? Let's say that the total length of the box was 4, and then we divide it into 4 pieces. Each one has a length of 1. How do we find the number of boxes? We take 4 divided by 1, which equals 4, or we basically take the length of the long one divided the length of the whole thing divided by the length of every small one. What is the length of the whole thing here? Well, it's whatever this length is. What is this length? It's b minus a. Does that make sense? B minus a gives us this length. So we take the length of the long one and we divide by the size of the small ones. What the small ones? Dx. That's it. This equals the number of slices that we've made. And so now we divide the sum of all the things by the number of the samples we have, which is here, right? Dx. And yeah, okay, that's it. So let's rearrange this a little bit. Let's say that let's move the denominator inside the denominator up. This is going to be 1 over, let's just do fx1. You know, technically this is just the sum of all the different fx's, you know, obviously from a to b, multiplied by dx. Or I guess it's another better way to show it is fx1 plus fx2, I'm going to skip fx3 this time, plus fxb, all multiplied by dx. Looks familiar yet, guys? So then all of this is divided by b minus a over dx. Remember from my previous videos that the sum is basically just the integral sign. if we had a bound and we are doing infinite slices. So we can say that this is the integral from a to b of fx. Yes, because it's a and then it's a plus 1 or a plus 0.01. All of this, oh my god, and then fx is multiplied by dx, right? And then all of this is divided by b minus a. Or in other words, we can write it as this. 1 over b minus a multiplied with the integration of a to b of fx dx. There you go.